Hi, the topic of this lesson is function y is equal to x squared and its graph. Let's try to build a graph of the function y is equal to x squared. To do this, let's make a table where the values of the argument x will be on the top and the values of the function y will be below. Let's put some values for the argument x and find the corresponding value for y. Let's start from 0 with x equal to 0. It is obvious that y is equal to 0 too. If x is equal to 1, 1 squared gives 1 as well. If x is 2, then y is 4. X is equal to 3, y is equal to 9. Please note that if I take minus 1 instead of 1, then with the square it will still be 1. If I take minus 2 instead of 2, then with the square it will still be 4. So instead of 1, I can write plus minus 1, plus minus 2, plus minus 3. So I've got 7 different points here, which I will mark on the graph. Let's plot the axis. This is the x-axis. This is the y-axis. Mark a point with coordinates 0 and 0. This is the origin. Mark a point with coordinates 1 and 1. You can mark it neatly in the cages, but I will do it by eye. Also mark the point with coordinates minus 1 and 1. Minus 1 for x here, 1 here. Mark point with coordinates 2, 4. And minus 2, 4. I also mark the points with coordinates plus minus 3 and 9, but it won't fit on my graph, so I'll skip this step for now. Now we need to neatly connect all these points with a smooth line. We've got this curve. This curve is a graph of the function y is equal to x squared. By the way, it is called a parabola. Let's note some properties of this parabola. We see that we have some minimum value at 0, 0. This point is called the vertex of the parabola. The so-called branches of the parabola originate from the vertex. We see that our parabola is symmetrical to the OY axis. Then we can say that OY axis is the axis of symmetry of this parabola. We also need to note such a property. When x, variable x, belongs to from minus infinity to 0, then the function y decreases. Pay attention that the function constantly tends to go down. Then it is said that the function is decreasing. If x belongs to from 0 to plus infinity, that is, in this section, then the function y increases. Note that the function y is always positive, except for the point 0, 0. Let's take a look at an example. We need to rebuild the function y is equal to x squared and find its smallest and largest value on the interval from minus 3 to 2. We will no longer build the graph by points, since we know how it will look like. Approximately, it looks like this. Here is the vertex. Now we need to find the largest and smallest value of this function on the interval from minus 3 to 2. Mark minus 3 on x. And mark 2 on x. So we need to find the largest and smallest value of the function in this section. The highest value corresponds to the point that is located above all of them, this point. It is the value of the point minus 3. We substitute minus 3 squared, it is 9. So the highest value in this section is 9. And we see that the smallest value is at the vertex, that is 0. Thus we have found the largest and smallest value. Let's consider another example. We need to plot the function y is equal to minus x squared. Let's also not build a table, just think about it. If our function x squared looks like a parabola of this kind, then how will the graph of the function minus x squared differ? We know that this parabola is always positive, except 0 point. Accordingly, the parabola with the minus sign will always be negative. Then the point with coordinates, let's say 1 and 1, will go down. The same will happen with the point minus 1, 1, and so on. Then we get, if we connect it with a smooth line, we get a parabola with branches directed downwards. This is the graph of the function y is equal to minus x squared. This video lesson is over.